Hello. So we have two parallel charged metal plates A and B that are in a vacuum. So on the diagram, at a particular instant, an electron is at point P. On the diagram, draw the electric field pattern due to the plates and an arrow to represent the direction of the force on the electron P. Okay, so let's grab our pencil here. So we know that we can see the direction of the electric field if we put down test charges, and we know that positive charges repel from positives, and positive charges are attracted to negatives. So we can denote them like this. So I'm just going to use copy and paste tool. I'm not going to overlap with the P though. Oh my god, this is kind of glitchy. Oh my god, what's it? Okay, can you go over there? There. Okay, I mean, it's still correct. Oh, okay. No, please. Okay, that's good enough. I looked at the answer key, they only had 4 arrows, so I think that's fine. And then we also have to account for the curves here. Alright, there we go. That's the basic idea of what the electric field pattern is. And we have to do the arrow to represent the force of the electron. Alright, so we know electrons are attracted to positive charges and repel from negative, so it'd be in the opposite direction. Okay, so the acceleration of the electron P is 8.8 times 10 to the 14 meters per second squared. Determine the magnitude of the electric field strength at point P. Okay, so what we know is the mass of the electron, we know the acceleration, and then we know the charge. So actually we can solve for it. So we can combine these two equations. So E is equal to ma over q. We know these three things. So we're just going to grab our calculator. We're going to type in m, which is 9.11 times 10 to the negative 31. Then we're going to type in a, which is given, times 8.8 times 10 to the 14. That equals, and then we have to divide by 1.6 times 10 to the negative 19. There we go. We're going to get left with approximately, I'll write down approximately. Approximately 5.01. That looks sloppy. I need a stylus to do this. 5.01 times 10 to the negative 35. This is going to be in newtons per coulomb. Sorry for the bad trucks. Okay, so next we have to find, the electric potential energy of the electron changes by 1.9 times 10 to the negative 17 joules as it moves from one plate to the other. Show that the potential difference between the plates is 120 volts. So we're given all three of these variables, so we just have to show. So we know that the work is given right there. 1.9 times 10 to the negative 17 joules. We know Q, well, that's just the charge of electron. So we type that in. 1.9 times 10 to the negative 17 divided by 1.6 times 10 to the negative 19. And we're going to get 1.18. Oh, God. Wait, one second. I need to type that in one more time. 1.9 times 10 to the negative 17 divided by 1.6 times 10 to the negative 19. Yep, and we get, not 1 point. Well, I don't know why I did that dot there. 1.18, 18.75. And we know 3 sig figs, right? So we know that would, sorry, not 3 sig figs in this case. We just have to show that equals, and that's approximately 120 volts. Thank you.